The Islamic Golden Age was a period of massive advancements and exchanges of scientific discovery in the Middle Ages. In the previous episode of this series, we discussed the factors which led to this explosion on nearly every intellectual front, and we explored the worlds of theology and philosophy which shaped it. Now let's delve into how this community of thinkers contributed to the development of our understanding of science. Shout out to Magellan TV for sponsoring this video. If you're a history fan, then you should be signed up to Magellan TV, a new type of documentary streaming membership with more than 3,000 titles and the richest and most varied history content available anywhere. Ancient, modern, current, early modern, war, biography, and even historical fiction shows. Any fan of history could spend days and weeks watching Magellan TV's historical documentaries and will still have content to watch. New documentaries are added all the time, it's like a rabbit hole. Recently we dived deep into the documentaries on the early modern period, and they're so awesome, especially the ones covering everything from Elizabeth I to other monarchs of the Tudor dynasty. Our favourite is the documentary on Joan of Arc, which destroys the myths and uncovers the truth about this warrior who saved France. You can stream Magellan from anywhere on any device without any ads and unlimited access. New programs are added on a weekly basis, and many of them are available in 4K. The best part is Magellan TV is offering a 1-month free membership trial to our viewers. If you haven't signed up to Magellan yet, support our channel and do that at try.magellantv.com/kingsandgenerals. You'll get a free 1-month membership trial. Thanks to Magellan for supporting our channel. The process for theorizing, testing, and analyzing through experimentation is known as the scientific method. For thousands of years, ways to systematically test phenomena to understand them have led to scientific breakthroughs. Discussions of scientific methodology have roots back to ancient Egypt and Babylon, but also independently emerged in ancient India among both Hindu and Buddhist philosophers. Likewise, scientific methods were a major subject among ancient Greek philosophers and physicians. Most important would be Aristotle, who developed methods of both deductive and inductive reasoning, and the often underappreciated Democritus, who wrote extensively of the existence of atoms, an object of matter which could not be broken down further, breaking reality into its constituent parts. This was all theory, however, and in the Islamic world, theory met with testing to develop the earliest experimental methods. Here, the idea of running experiments and using measurement to test different hypotheses came into its own. Many of the great thinkers of the Islamic Golden Age were polymaths and generalists, so many names will appear again and again as they worked in different areas of study. One great developer of experimental methods is one of the great minds of the age, Hassan ibn al-Haytham. Al-Haytham was born in what would be modern-day Iraq, and did much of his work serving as a vizier or political advisor to the Buyid Emirate. Using logical reasoning, combined with empirical experimentation, he disagreed with many Greek philosophers on the nature of light and vision, which we will discuss later. Al-Haytham saw himself on a quest for truth above all else, noting that it's difficult to find a hard path to make the journey. He practiced a process of relentless skepticism and finding the truth through observation. This thinking is an early form of positivism, or the theory that knowledge about natural phenomena can only be derived through observation and reason. Furthermore, Al-Haytham's writings indicate a form of using the principle of Occam's razor, or choosing the option with the fewest number of assumptions when selecting between different explanations for phenomena. He often pointed out frustration with the lack of development of such thought in ancient Greek texts. What Al-Haytham did through his work introduces the idea of induction to scientific methods. As opposed to deductive reasoning, where one removes possible explanations for phenomena until only one remains, induction builds a collection of evidence and uses reason to find a theory which is the best explanation given what's at hand. This thinking is the philosophy behind modern science. Another developer of the scientific method in this age was the ancient Persian scientist Abu Rayhan al-Biruni. He took an even greater interest in systematic experimentation to find natural principles. Al-Biruni made much emphasis on the repeatability of experiments, a cornerstone of the modern scientific method. He showed concern with making sure to prevent bias in observation, and so often repeated experiments many times. Al-Biruni desired to make averages of outcomes to compensate for the errors inherent with tools and the humans who used them. These advances would found the basis of scientific development throughout the Middle Ages, and the scientific method would not go through further development until well into the 12th century, 100 years later. Islamic scholars also made marked developments in the area of mathematics. In many cases, they built upon scholars from around the world to cross-pollinate some of the most foundational parts of our understanding of numbers. We can start with the numbers themselves. The current system we have for the writing of numbers goes by the colloquial term Arabic numerals for a reason. The Arabic numeral system is an excellent example of the factors which made the Islamic Golden Age so impressive. The number system has its origins with Hindu mathematicians in India in the 8th century, including the concept of a number zero. From India, it came to the court in Baghdad, where it attracted the attention of the brilliant working mathematicians in the bustling city. Most importantly, it came to the attention of Persian mathematician Muhammad ibn Musa al-Khwarizmi. In 820, he published On the Calculation with Hindu Numerals, advocating for the mass adoption of a base 10 numerical system, which made doing mathematics much more manageable. The book would be copied and translated across Eurasia and North Africa. Its Latin translation was Algoritmi de Numero Indorum. This Latinization of al-Khwarizmi's name would eventually serve as the origin of the term algorithm. Within 100 years, Islamic scholars took this contribution, spread it, and began developing new and ingenious uses for these numerals, including the first case of using decimals to record fractions. This powerful new way of symbolizing numbers was not the only contribution of scholars of the Islamic Golden Age to mathematics. One focus of Islamic mathematicians was the development of modern-day algebra. The word algebra comes from an Arabic term for reuniting broken parts. Al-Khwarizmi was also a major scholar who, along with the Greek mathematician Diophantus, has the title of the father of algebra. Much of his work concerned techniques to reduce polynomial equations. A different mathematician, Omar Khayyam, built upon al-Khwarizmi's work to develop the world of cubic equations. A different Egyptian mathematician, Abu Kamil Suja ibn Aslam ibn Muhammad ibn Suja, would expand on al-Khwarizmi's work into an exploration of negative numbers and their notation. Outside of algebra, mathematicians during this period also made significant developments in areas such as induction, the working with and notation of irrational numbers, and the spherical law of signs. This work would then translate into massive developments during the Islamic Golden Age in the scientific realm of physics. Before Newton's laws of motion, Islamic physicists developed concepts of acceleration, reaction, and impetus. Many were early developments of what would eventually become Newton's laws of motion and Newtonian physics in general. But where physics developed in the Golden Age was the area of optics, or the study of the properties of light. Development of laws of refraction and reflection began under the Baghdad physicist Abu Sa'd al-Ala ibn Sal. He wrote an influential treatise investigating how curved mirrors bend and focus light, developing the first law of refraction, and inventing anaclastic lenses, a critical early invention in the development of eyeglasses and eventually the camera. Then optics would change entirely once Al-Haytham began to work in the field. The same Al-Haytham who pioneered the scientific method also often receives the title of the father of optics, and not for no reason. He began his work analyzing the work the Greeks had done on reflection. In his famous book on optics, he published significant disagreement with the likes of Ptolemy and Euclid on the nature of vision. The Greeks firmly believed that eyesight worked much like sonar or radar, that light was emitted from the eyes and reflected to give sight. Al-Haytham disagreed, and postulated correctly that light reflects into the eyes and could explain with lenses the physiology of eyesight, in doing so developing the camera obscura, He also sought to understand the nature of the movement of light like that of the movement of objects, noting that many of the laws of motion seem to apply the same way. And the scientific development didn't stop there. Another place of significant growth was the field of astronomy. Much effort went into developing astronomy as part of a project to determine Qibla, the direction of the Kaaba. In Muslim prayers, one is expected to perform them facing Qibla anywhere on earth. They also used astrology to determine when to perform important actions. Developing these fields, polymaths like al-Khwarizmi also published documentation of the movement of the sun, moon and planets. Centuries before Galileo, many Islamic astronomers expressed doubts in the prevailing Ptolemaic understanding of the cosmos, the idea which places the Earth as an immobile center of the universe. While none of them ever stumbled upon a heliocentric model, there was a definite growing suspicion that Ptolemy's model of the universe did not hold up under observation and mathematical modeling. Looking back down on Earth, Golden Age Islamic scholars made significant advances in geography, as well as a very dear subject to kings and generals, cartography. The Islamic Age was full of Muslim explorers. They documented exploration ventures as far east as China and south as southern Africa. Maps were also integral for many aspects of maintaining such a massive empire, for the everyday needs of outlining just which territory kings managed, as well as making troop movement plans for generals. Because of this importance, geography and cartography were well-funded priorities of the Abbasid caliphs. To refine the mile, scholars wound up calculating an impressively accurate estimation of the circumference of the Earth. The earlier developments in spherical trigonometry, like the spherical law of sines, allowed for Islamic geographers to develop better and more accurate methods of map projection, and even the very early beginnings of the polar-based coordinate method. Moving on to the realm of chemistry and material science, the Islamic Golden Age saw an explosion in the understanding of chemistry and the nature of compounds. Those who worked with materials in various ways were called alchemists. At this time, most of the ideas of the properties of materials were a combination of four essential elements: fire, earth, air, and water. Each one was a combination of hot and cold and wet and dry. The fire was hot and dry, earth cold and dry, air hot and moist, and water cold and moist. This concept of the material world is not merely the basis of chemistry, but of medicine. Before the discovery of germ theory, disease was thought to be one of these attributes being out of balance within the body. Persian alchemist Abu Musa Jabir ibn Hayyan wished to build upon this. As just one part of a truly massive body of work, touching on everything from alchemy to astrology to philosophy, Ibn Hayyan looked to sort the Earth's metals by the Aristotelian model. What he theorized was that metals were fusions of mercury and sulfur made deep within the Earth. What was most important, however, was that he believed making different combinations of different materials, he could produce a fundamentally different metal. What seems like an implausible assertion today would have significant impacts on the world of alchemy. Part of the goal of the profession was the quest to turn substances into other substances, most famously lead into gold. Ibn Hayyan's reasoning introduced the idea that a different metal, when mixed with something like lead, could produce gold. The search for this metal was of significant importance to Western alchemists, gaining the nickname the Philosopher's Stone. This work was not a significant contribution to our modern understanding of chemistry. It comes from a pre-scientific time, and alchemists, like many in the physical sciences, relied on only the theories they had around to work with, and their methods of observing and testing experiments when they could. In the endeavor to discover the properties of these materials, while drawing the wrong conclusions, they however came up with various chemicals and inventions. We will discuss those more at length in a future video in this series. In working with these materials, Islamic scholars seem to have developed distillation, evaporation, and sublimation. Our last stop on this tour of Islamic contributions to the sciences in this period is biology. In areas such as agriculture, the Arabs led a revolution in the sciences of cultivating crops and livestock. What the age managed to do very well is take staple Mediterranean crops such as olives and dates and make information about best practices available to a vast body of people. Agronomists like Ibn Basal of Toledo traveled across the Islamic world, learning and studying how farmers practiced their work in different lands. He documented nearly 200 species of crops and wrote practical guides on the proper care of them. In many ways, this period birthed the idea of the academic study of agriculture. It began a dialogue between farmers and agricultural scholars, which would not only vastly improve the quality of farm goods, but prompt a search for new farmable plants and agrarian experimentation. Archaeologists can measure the improvement of food production and thus population figures from these advancements. They can see evidence for the revolution in areas such as studying the size of sheep bones to see their growth, indicating improvements in animal husbandry. Likewise, irrigation improved with the introduction of various ways of pumping water into fields using animals, the wind, or even water itself. In places with ancient Roman aqueducts, such as the Andalusian city of Cordoba, they were repaired and brought back into use, even expanded. Further study of animals came from translations of Aristotle's zoology. Islamic zoologists used this famous translation as they categorized various animals and catalogued animal parts, one of which is the most important, the human body. Next time, we're going to focus on the development of the understanding and treatment of the human body during the Islamic Golden Age, so make sure you are subscribed to our channel and have pressed the bell button. We would like to express our gratitude to our Patreon supporters and channel members who make the creation of our videos possible. Now you can also support us by buying our merchandise via the link in the description. This is the Kings and Generals channel, and we will catch you on the next one.